topic in our physics subject be heat. So what comes into your mind when you hear the word heat? So heat and temperature. So usually they are being associated, but what's the difference between the two of them? So up to the middle of 19th century, it was thought that heat was an invisible weightless substance called caloric fluid. When wood, for instance, is burned, it is hot because it produces large quantities of caloric fluid, which is transferred to other substance close by. So the burned wood, having lost its caloric fluid, is said to have cooled off. The theory of caloric fluid was disapproved around 1800s by Count Benjamin Thomson Rumford, an American-born physicist. Count Benjamin Thomson Rumford concluded that heat was produced from friction alone. Hindi siya caloric fluid, but from friction alone. No? When we rub two stones together, no, it produces a spark. Kag na-use ang una sa mga people, no, living sa aton na mga sinanguna as a source of heat or a source of fire. So it was only about 40 years later that an English physicist, James Prescott Joule, proved that a measurable amount of mechanical energy could always be transformed into definite amounts of heat. Meaning, kung ma-measure nimo ang mechanical energy, na-measure man nimo ang amount of heat nga iya gina-produce. That was the theory of Mr. Joule. He concluded that heat must be just another form of energy. So sources of heat, you have the natural sources. Number one is the sun. When sun's energy reaches the earth, 30% of it is immediately reflected back out into space. Only 70% remains to interact with the earth and warm it up. Of the 70%, 20% is energy to heat both the surface of the earth as well as the ocean. It is the sun's heat energy that makes plants, animals to provide themselves with energy. These plants provide food for animals. Humans eat plants and animals to provide themselves with energy. Much of the heat on earth may be traced back to the sun. So most of the things nga nag-needs ng heat, it is produced by our sun. So we know during photosynthesis the plants need the heat. For the people, we need also heat to produce the ATP. Number two, aside from the sun, is the interior of the earth, meaning the core of the earth has its own source of heat. A great amount of heat also comes from the buried hot rocks and lava flow from the craters and crevices of erupting volcanoes that spring in Tiwi, Albay, Los Baños, Laguna, and in Tayabas, Quezon are proofs that the Earth's interior is much hotter than its surface. Meaning, ang core niya mas init kumpara ara lang sa surface because ginaganit no ang surface naton and our ocean and our water ng mga bodies of water, no, its heat source is from the sun. But ang aton nga core or the interior of the earth has its own natural source of heat. So next, kung may ara natural, there is also an artificial sources. One is the chemical action. So when fuels like coal, kerosene, wood, and gasoline are burned, they are used as artificial sources of heat. Pagsubong, amo na ni usually ang ginagamit natin as sources of heat in our houses, in our daily living. So the oxygen we breathe in burns the food we eat, producing enough body heat to keep our body temperature close to 37 degrees Celsius. We know nga ang normal nga body temperature should be within 37 degrees Celsius to 37.5. So next is the mechanical action, heat energy produced by a friction. Muna kagina ang theory ni Joule. And then the electrical energy. Electricity is a very common source of heat at home. You have oven toaster, electric iron are heated by the resistance of heating coils with the electricity passing through them. Next is the nuclear energy. The tremendous amount of energy from nuclear reactions can be used to change water into steam, which is then used to operate turbine to generate electricity. So you have the nuclear plant na subong, no, from bodies of water or from different nga nuclear power niya ang water into steam, and then pwede siya ka-generate electricity. So temperature scale, the most common thermometer used in the laboratory is the mercury thermometer. Amo gining nadak-anta, amo gining usually naton nga ginagamit. So these are the different kinds of the thermometer. You have the mercury in the bore of the tube, sliding maximum marker. So dira na daw siya nag-stop kung diin lang hasta ang temperature nga ma-measure niya, the graduation, the measurements, and the capillary tube. Ang bulb, diri naghalin ang atong thermometer, and then it goes up when the temperature rises up also. And then the colored alcohol is another liquid commonly used in thermometers. So not just the mercury ang iba na ginagamit, but also the colored alcohol. So Celsius scale, this is commonly known as the centigrade scale. So usually, in measurement of our temperature, usually it's in centigrade scale or in our degree Celsius. This scale was devised in 1741 by a Swedish astronomer Anders Celsius based on the properties of water. So on the Celsius scale, the freezing point of water is fixed at 0 degrees Celsius. The boiling point of pure water under normal atmospheric pressure is 760 mmHg. This is your unit for mercury. At sea level is 100 degrees Celsius. So ang atom ng water may boiling point siya sa 100 degrees Celsius. The normal temperature of the human body is 37 degrees Celsius. Fahrenheit scale. So the Fahrenheit scale was devised by Daniel Gabriel Fahrenheit, a German physicist. United States of America and England used the Fahrenheit scale for weather observation and other purposes. So for us in Asia, usually we use the degree Celsius, but in Latin and in Western mga countries, they usually use the Fahrenheit scale. On Fahrenheit scale, 32 degree Fahrenheit is the freezing point of water, and 212 degree Fahrenheit is the boiling point. In Celsius, 0 degree Celsius is the freezing point. And then, ang boiling point is 100 degrees Celsius. But in Fahrenheit, the freezing point is 32 degree Fahrenheit and 212 degree Fahrenheit for the boiling point of the water. Next is the Kelvin scale, or the absolute zero. So named after Sir William Thomson or Lord Kelvin, who devised it. From his name, Kelvin scale, Lord Kelvin. This temperature scale is often used when gases are involved. Its 0 point corresponds to negative 273 degrees Celsius. That's why it is called as an absolute zero nga scale. It's because ang sa aton degree Celsius ang zero freezing point na sa water. But sa Kelvin naton, nag-correspond siya sa negative 273 degrees Celsius and is referred to as the absolute zero, or the temperature at which the molecular energy of matter is minimal. On the Kelvin scale, the freezing point of water is 273 degrees Celsius and the boiling point is 373 Kelvin. So, muni Fahrenheit, boiling point of the water, 212 sa Celsius, sa Kelvin naton. So, may different conversion sila. So, to convert temperature readings from one scale to another, the equation below are used. So, please memorize this formula and be familiarized with it, how it is done. So, converting units of temperature from degree Celsius to degree Fahrenheit. Ang formula, degree Fahrenheit, 9/5 times degree Celsius plus 32. So, example, 38.7 degree Celsius i-convert natin sa degree Fahrenheit. 9/5, kung i-divide siya natin, it is equals to 1.8 times 38.7, ang given nga number for our Celsius. multiply is equals to 69.66 plus 32. 32 is constant given na niya siya already. So 38.7 degrees Celsius to Fahrenheit is 101.7. Next, degree Fahrenheit to Celsius naman. Kung mag-convert naman ta from Fahrenheit to Celsius, so we have the formula, degree Celsius is equals to 5/9, close parentheses, open parentheses, degree Fahrenheit minus 32, close parentheses. So, ang given is 101.7 degree Fahrenheit to Celsius. So, 5/9 divide is equals to 0.55555. And then, i-minus natin ang 101.7 minus 32 is equals to 69.7. And then, multiply 0.555 with 69.7 is equals to 38.7 degree Fahrenheit. How about degree Celsius to Kelvin? Kelvin is 273 plus degree Celsius. Ang formula. Very easy, no? So, 273 plusan mo lang sang degree Celsius. So, 38.7 degree Celsius to Kelvin. 273 plus 38.7 is equals to 311.7. So, if you have any question about that one, you can chat me or you can ask me, no? So, how heat is measured? Thermometer only gives us an idea of the total potential energy and kinetic energy of the molecules in an object. It does not tell us how much heat a particular object absorbs or gives off. So, ang atong thermometer, potential energy lang ang iya nga ma-absorb or the kinetic energy lang only of the molecules in the object. But, hindi ma-measure ang heat sa particular object na iya gina-absorb or iya ginahatag. In fact, there is no instrument that directly measures the amount of heat energy that a body gives off or absorbs. If you want to calculate the amount of heat given off by a piece of charcoal or a certain kind of gas, then you have to determine the change in temperature it produces on a definite volume of water. Because, kung galain ang volume sang water, galain man ang heat na ma-produce ang charcoal or sang certain kind of gas. We know ang charcoal nga nagabaga kung bubuan mo tubig, eventually kung damo-damo ang tubig kakapatay siya. So, that's all for our topic sa heat. We will continue it